Hello everyone, and welcome to this new series about microservices on Azure. I'm Nicolas Yuen, and today I'm with Stanislas Questana. Hello Stan, how are you?
I'm fine. Hello, Nicolas.
All right, let's have a look at the agenda for the series, and then we'll dive into some new topics. So the agenda for the series is first we'll start simple. We'll do a quick recap about cloud computing. Then we'll move on to best practices to develop cloud native applications. Then we'll talk about containers, containers orchestrators, and the life cycle, release cycle, and deployment cycle using Azure DevOps. And finally, we'll talk about application and platform updates and monitoring for container platforms. So quite a bit of topics. That's why we split this series into multiple sub-presentations. So back to basics first. Let's have a look with you, Stan, on the basics of cloud computing.
Yes, first of all, it's important to be very clear in your mind about the cloud models we have. The most well-known cloud models are the software as a service, the SaaS, and SaaS is just a software that somebody else is managing and operating instead of you. So you're basically just a consumer of the software as a service solution. You pay for that. You pay most of the times you pay a fixed price per user or per device every month, and you are just using and consuming the services that is managed by someone else. There is another layer below that is a platform as a service where you have some services that are ready for you to use. For example, you can have, for example, database as a services, and you are just coming with your database data and tables, and you put your data inside, and you don't have to manage the database by itself. I mean the engine of the database or the operating system and the server that are running this database. So on a platform as a service, you will put some services. Database is an example. You can have web app services, container services, and so on. And you just build your application on it. Below, we have the infrastructure as a service, the IaaS. That is basically just a super layer of virtualization where you will manage virtual machine, networks, storage, identities, and so on. And you will build, you have more things to build on the top of that because it's just on the layers that are below. You will have more works to do. There is less managed services, of course, because you will be the manager of these services. The cloud provider will just give you all the keys to create your VMs, virtual networks, storage, and so on. And below all these layers and cloud models, you have the real infrastructure, physical infrastructure, the data centers, that in the public cloud approach is managed by the cloud provider. In this series of video, we will talk about Azure. Azure, most of the services on Azure are on the IaaS or the PaaS layers. So for the models, if we're talking about software as a service, most of the time we are talking about when we are working with Microsoft, with Office 365, with Dynamics, CRM, with Intune, and so on. In this series of video with Nicolas, we will talk about container as a service. And container as a service is somewhere between the infrastructure as a service and the platform as a service. That means some of the sub-service will be fully managed, so it will be PaaS solution, and some service will use some virtual machine or virtual machine scale set, so it will be infrastructure as a service. So the container as a service is it's a gray area between the infrastructure as a service and the platform as a service. And we will see that later in the series of webcast. So, and also it's very important to well know the cloud shared responsibility models. It depends on if you are using infrastructure on site where you are the full manager of everything and you stop your responsibilities at the edge of your network. On the other side, you have the public software as a service, where basically, as a consumer of the service, You are just responsible of which data you are putting inside the service. And in this series of videos, we will talk about the container as a service. And as I said just before, it will use some services that will be a full infrastructure as a service, and other will be a managed service, so PaaS services. That means you have to be very clear on which responsibilities you have when you are choosing a service. If you are using an infrastructure as a service, the responsibility of the cloud provider will stop at the layer of virtualization. That means that everything that is running inside your VM will be up to you to manage. And in a public platform as a service, a lot of parts of the service will be managed by the cloud provider, and you will just add your application and your data. So, Nicolas, we are talking in this series of video about cloud native application. So we will see later in this webcast, this one, what does it take to build a cloud native apps, but what is finally a cloud native apps?
All right, let's see what it takes to build a cloud native application. And before we dive in, we want to talk about the 12-factor apps, which is key when we talk about building cloud native application. So the 12-factor app is a manifesto that has been made to build software as a service applications. It's quite old now. I think it's about 5 to 6 years old, but it's made about 12 simple rules that when you take them all together, allows you to build highly scalable and available applications. So this type of application have some things in common. First, they will use a declarative format to set up automation and minimize the time and cost for developers to join and onboard on the project. Second topic, we have a very clear contract with the underlying operating system. And the key is to have maximum portability between execution environments, so essentially when you move from development environment to production environment. That's suitable for deployment on modern cloud platforms. Obviously, we're talking about cloud native applications here. And we want to minimize the divergence between production and development environments to enforce continuous deployment for maximum agility. Last point, it's all about scaling without significant changes to the architecture of the application. When we talk about architecture, it can be the code, but it can be as well the underlying public cloud architecture. So let's have a look at these 12 rules, which are, again, when you take them one by one, they're very simple. When you assemble them all together, they do allow you to create a highly resilient application.
Yes, as you said, the 12-factor app is not mandatory, it's just a manifesto, but it was created with the experience of some people that operate a large-scale software as a service and large-scale web application. So they learn about their mistake during many years. And now if we are following all these 12 points, it will be easier for you if you want to create really an application that can scale, that can be highly available. So you don't have to reinvent something that was already tested and approved in production for many years.
So let's have a look at the very first factor, the very first rule. First one is about code base. So one code base to track the revision as a revision control. And we'll have here the code base of the application, but as well the code base of the infrastructure. Point number two, never rely on implicit existence of system-wide packages. For instance, it could be unzip configuration, a binary that is assumed to be deployed on the production environment. And we should never make assumptions about what's installed in an environment. We have to explicitly declare any single piece of software that has to be installed in a specific environment. So maybe, Stan, you can give me an example about what's an implicit and an explicit configuration.
Yes, for example, as a developer, you are packaging your application to give it for integration to the ops team. And when the ops teams, so to help the ops teams, you create a small bash script. That will be very simple. The bash script will just do a curl to get the package The package is a zip file, and the script just unzips the zip file. So you give this this very simple script to the integration teams, and when the integration teams they run the script on the server, that are the server running in production, what you get is just an error message, because basically the developer, he has all the tools he needs on his computer, and he assumes that these tools will be available also on the target systems. But as an ops, as an IT, you probably want to have the small footprint of your system, so you are just installing what you need, and most of the time you don't need an unzip or a curl on a base system. So in that case, when the ops teams, when they run the scripts will fail because they didn't know that you need before to have a curl install or unzip installed if they don't open the file and check what was inside. It's a very simple example, of course.
So rule of thumb, never assume that
Yeah.
what you have installed on your development environment will be available on the production environment.
Yeah.
If you need something on production, just make it explicitly required as a dependency, and use dependency management tools to configure as well the production environment.
Yeah, that's true. So don't fall into the very common sentence that is, it works on my computers. When the devs are saying this kind of sentence to the ops teams, it's just ridiculous, because if there is an issue for deploying the application, the issue is because the developer was thinking that implicit the tools were also installed on the server in production, and this is not the case. So you have to explicit everything that you need for running your application.
Point number 3, strict separation of configuration from code. The code is built once and is deployed in multiple environments and never changes. So when you move from development to production, the code is released and the binary version is the same. What will change is the configuration. So you can have a different configuration for different environments, potentially with different connection string to a database, different settings for the application, but the binary itself and the release package that you have has to remain the same.
Yeah, if you recompile, rebuild a new application for a new environment, then you have a problem, because you will never test really in pre-production or integration your application before going to production.
You will essentially test different releases,
yeah,
and you will introduce different configuration, different settings between the environment, and that's not what we want.
Yeah.
Right, next step, processes are stateless and share nothing. So any data that needs to be persisted must be stored in a stateful backing service, typically a database. It can be a Redis cache, it can be a highly distributed data store, it can be a blob storage or even a queue. Essentially what you're trying to achieve is not to store anything in an instant of a process, because if that process fails, then we're losing some data and we're going to have a bad user experience. So really we're trying to not store anything into the processes and outsource everything to a backing service that will give us more resiliency for the application and better scaling capabilities. Second point, the application is completely self-contained. We do not want to rely on runtime injection for web server into the execution. So essentially, we want to have something which is standalone that can run without a web server and a specific configuration. We don't want to rely on third-party servers. We want to have something autonomous and something that can be built and run by itself. Typically, we have web applications, we have APIs that will bind to a port on the environment, and we'll use that to access the service. Point number 3, the process model truly shine when it comes to scale out. So it really relies, it's really linked to the stateless and share nothing approach. Here we want to maximize scaling through horizontal scaling as opposed to vertical scaling. So that's how we make scalability easier. It's a bit harder to develop. There's a bit more configuration with the load balancing and the networking, but it gives us so much more capabilities when it comes to scaling. Vertical scaling will reach some limits. And if you go back to the core of the manifesto is about being able to scale without doing major changes of the architecture. And really, this is one key point, is about the share nothing model and the horizontal partitioning and scaling.
You need to have to maximize the robustness with fast startup and graceful shutdown. So you don't want an application that needs to warm up before serving some page, for example. It must be very quick. The processes are disposable. That means they can be stopped at any moment. It will be especially interesting if we have a stateless environment, of course. Keep in mind that you have to keep the deployment, staging, and production as similar as possible. That doesn't mean that you need to have the exact same platform on both sides. That just means that if you are using some component on a platform, for example, in test and dev, you need to have the same component in the production. For example, if you are using in production a special load balancer or a web application firewall with special settings, you need to have the same component also in the dev and test or the pre-prod environment if you want to test everything before going in production. That means also you need to have the same version. If you are using a database, for example, SQL Server 2012 in dev and test, and if you are running in production the SQL Server as Azure SQL database, so in evergreen mode, or SQL Server 2019, it will be different from the test and dev environment. So try to be at the same level of software, to have the same component. It can be less powerful, of course, with less number of instances in pre-production or in test and dev environment, but it must be the most similar as possible. So keep the gap between the development, between the production and everything else, the smallest possible. And resist the urge of using different backing services between the development and production. For example, you are using in pre-production some operating system that are not the same that in production. For example, you're using Ubuntu or CentOS in pre-production and you're using a Red Hat Enterprise Linux server in production. It will make some difference, and at the end the difference are not very good if you want to test everything before going to production.
So essentially, it's all about consistency, making sure that we don't have any differences between the environments. Scaling and the size of the environment can change, but not the version of the runtime of the configuration and the operating system.
Finally,
all right, so finally, it's all about logging as well. So when we talk about cloud applications and applications which are built on multiple processes or even microservices, we'll talk about that a bit later. We want to make sure that we treat the logs as an event stream. We don't want to have to deal directly with the logs within the code of the application or the operating system. We want to outsource all the logs to a platform, so hopefully a managed platform. And we simply want to output the logs into a stream, and the stream will then capture the log and store them somewhere for analytics. So really, we want to be able to scale again. We have processes that will start and stop. We talked about disposability, and we talked about horizontal scaling. So once you have that, it's not really an option to go into every single service and try to get what's going on in the application. You need to outsource that to a main platform, a system, where you can treat the logs, analyze them, and do queries. Very last point, I think that's point number 12, run the admin and management task as a one-off process. Admin code is code as well, and we talked, the very first point was about GitHub and code repository. Admin code must be shipped as well with the application. So the admin code is versioned just like the application, and we want to avoid synchronization issues between the administrating code and the processes, the batch processes, or the scripts that you might run on your production environment with the release of your code. So again, version everything. If you have a release of the application, the admin task and the batch processes that you have must be versioned as well and must be updated when you do a new release. And you run this It's admin code and admin scripts against a specific environment.
Yeah, and don't forget that documentation also can now be included in the source code, especially if you're using Markdown, for example. So codify everything, including your documentation. And remember, for example, the documentation on Microsoft.com for Azure, for example, is all done on GitHub, and you can do something on that. You can open some issues and do
The
some
last point I
correction.
would add is
Yeah.
the documentation is for everyone. The GitHub, the repository is for everyone to contribute. So developer and administrator or anyone who is working the project can have a look at the documentation, update the documentation to pull request. So it's a common effort, right? It's not just one person who's doing the documentation. Everybody has to review that and fix the documentation. And that's exactly what we're doing on the Microsoft documentation as well. We've seen the 12 factors up. Now let's move on to the Conway's law. And I think, Stan, this one is for you.
Yeah, you probably say that because I'm a bit older than you. But this law is very old. It was in 1968 that Melvin Conway says that any organization that design a system, define it broadly, will produce a design whose structure is a copy of the organization communication structure. So it's a bit complex when we say that like that. There is a better version, a more modern version that Clément Rochas, that is a DevOps, said during a conference in Paris, the org chart of the company has a direct impact on the code. That means simply that if you want to change from an old model application to something that is more modern, a cloud-native application, you need to change also the structure of your organization and the way that people will work together. If you don't change, if you change nothing inside your organization, the way the teams are structured and the way they are working together or not together, at the end, even if you want to make a modern application, you will not get it. You will get something that is very close at what you had before.
And when we talk about code, right, let's go back one slide. Like when we talk about code, we talk about the application code, but we talk about as well the infrastructure code or anything which is related to deployment and the development of the application. So essentially,
Yeah.
the infrastructure, the code of the app, even the structure of the app will be very related to the way your organization is structured.
Yeah. And as I said, it's a very old law that Conway's Melvin said in 1968, but it's still applied today. A lot of years.
Many organizations, yeah.
Yeah, many organizations. That's true. So, and there is probably a reason for that. Also, that we all have a tint. We can be a blue or red. You can be an IT or a dev, and basically there is a reason for that. The reason is based on your education. Maybe during your studies you learn some dev tools or dev approach, and your studies were more focused on development. Or on the other side, it was probably also some studies on networking or system administration and so on. So you start with on one side of the story. It's very rare that you are both very in the center of this. When you will do your first work experience, you will be probably a dev or an IT. Most of the time you are not both of the profile. And depending also on what you like to do or what you dislike, you will probably going to the dev side or to the ops IT side. Because of that, traditionally, in the traditional way, you have some teams into the organization that are separate. You have the developer on one side, and you have the rest of the people, the ops, the IT, the database administrator, the security guys that are on the other side. And in the traditional way, the developers, they produce the code based on specifications that were given to them by the manager or by the business unit that wants some new feature, for example, or a new application. And historically, the developers, they have limited concern and implication on how the code is run and deployed after they finish to code the application. So on the side of the developer, the implementation task seems done when the build is done and when the package is given to the integration team and deploy and then run into production. On the other side, the ops team, the IT guys, they are more focused on the stability and the performance on their platforms, and they really, most of the time, don't really care about the details of the running application. We give them a lot of applications. They are trying to run it on their platform, and if there is an issue, for example, on the performance side, they will check if it's due to their platform. And if it's not, if it's really the application that is consuming too much CPUs or RAM and so on, they will just say, ask the dev team because we don't know how it was coded. In the DevOps way, that is a new way, probably a better way for cloud native application, we have a shared responsibilities and accountabilities of a teams composed of people that are dev and ops. Dev and ops, DevOps means it's a contraction of developers and operating ops that are working together. So everybody is in the same boat. So when everything is running well, the application is good, performance are good, customers are happy, you are the king of the world. And both the dev and the ops, it's the same team. But when there is an issue, everybody is on the same boat. So the boat is sinking and every member of the team is implied if there is a problem. So no finger pointing in that case. I think one of the good examples is Amazon, the e-commerce website. And in 2011, so it's almost 10 years ago, the CTO of Amazon having an interview for the Next Web. And in his interview, he said a sentence that is very famous now. It is the mantra inside the Amazon website teams say you built it, you run it. So you can imagine that every big e-commerce platform is not a monolith application. It's a composition of a lot of microservices that are running together. And for example, when you are on the front page, on the main page of an e-commerce website, you will see probably some banners for promotion. You will see the basket, an icon basket. You have probably somewhere where to log. You will have some products that will be in the front page. You will have some recommendation and many features. All the features in that case are separate most of the time, microservices that are managed by different teams, and each team is responsible for this feature. And in the case of Amazon, the rules is very simple. So you build it, you run it. That means the teams that are responsible, for example, a feature, like for example, the basket on the e-commerce website, they are responsible for building the feature, making some evolution on the feature and run it in production. So there is no separation of commitment between the guys that are developing and the guys that are operating.
So essentially, making sure that everything stays up and running without bugs, and that everything is stable and does meet the customer requirements, right? And it does bring a shift to the organization. So that's back to Conway's law, where here we don't have two teams doing on one side the development and on the other side the operation and the maintenance of the servers. We have one team working together with the shared responsibility model and being accountable for the outcome of the build, the runtime, and the performances, and essentially whether or not customers and users are happy about the solution or not.
Yeah, and to do that, we will see that later. You can't have big teams composed of dozens of people because it will be too complex to have a single responsibility as a team. So in the case of Amazon, and you can, this example is a good example for many other organizations that are doing this kind of approach. You will have some small teams composed of dev and ops and DBA and security guys. And these teams are, in the case of Amazon, but the industry keeps this name. it's two pizza size teams. That means teams that you can fed with two American size pizza. It doesn't work in French, for example. Pizza are too small here.
So yeah, it's about having a team that can communicate, and the team with multiple skills and multiple backgrounds can work together and exchange together, right?
Yeah, right. And you're talking about skills. It's important to say that when we are talking about these small teams, we can speak about DevOps because we will not have in the future world people that are really super specialized of one feature, one software, one platforms. Most of the time, these kind of teams, because the responsibility is at the team levels, so everyone must understand what his partner in the team is doing. We will need to have more knowledge about almost everything. So a deep dive specialist in one solution is probably not the people you want for that team. You prefer probably some people that are more open-minded, that can be that have an overall vision of the solution and can be ready to learn some new product, new features, new tools, and so on. The DevOps approach and the cloud native approach is using a lot of open source softwares. Is using some projects that are open on GitHub and things like that. And you need to be curious when you are working in this kind of teams because you can stay in the corner of a room and say, oh, I'm just a specialist of Windows servers and I don't want to see what is Bash, what is this solution and this solution. So now we will, as I said before, with the blue pill and the red pill, now we are more becoming most of us some purple or pink pills because there is no a strict separation now because what is a dev and what is ops, basically.
Right. So essentially, DevOps, you said it's all about collaboration and working together. And when we talk about DevOps and trying to explain it, what is DevOps, we always see this diagram with the infinity loop. And you can see that loop from the perspective of an ops or a developer. It's the same because it's the same team working together. They will work together hand in hand. With first the planning phase, they will decide what's the application about, how we're going to build the application and deploy the application as well. Then we'll move to the coding phase, which is obviously more related to the devs. The build phase, hopefully with a CI/CD pipeline, which will be automated, and the ops team will have their word to say on that. Then we're going to test everything and test the application, test the infrastructure, so doing performance testing, unit testing, integration testing, and then we're ready to move to release. A release will be versioned. We'll have the release of the maintenance tools as well. Everything will be in the central repository, and then we'll be able to move on to deployment phase, the release phase, and then the monitoring phase. And the monitoring is a key part of the DevOps aspect. It's all about learning from what's working, learning from what's not working. And when we deal with monitoring, we deal with performance monitoring, application monitoring, and business outcome monitoring. We want to know if the application that we built, that we spend so much time working on as a team, is effective and is meeting the business outcomes. So really definitely the monitoring plays a super important aspect because then we'll use these metrics and we'll use this data to move on to the second plan phase and do this cycle again to enhance the application, make new features, make the application more stable, reduce maybe the cost of infrastructure. So everything again is related. And that's why you see, especially with cloud computing, that the development team and the operation team and even the business team have to work all together. So let's have a look at who can apply DevOps, right?
Yeah,
who is it made for?
Just before, I'm cutting you, sorry, but I very like this slide because every time you're starting this slide, you're talking about coding as a developer and so on. And it's because of your background. As I said,
Absolutely,
you are
yes.
the blue pill. I am the red pill because my background is more on infrastructure and your background is more on dev. And every time you're starting about talking about coding in this loop,
Application coding, yes.
and in
And
fact,
I
it's
know
not
what you're
application.
thinking.
Yeah, yeah, yeah.
Now you're
But
thinking about infrastructure coding and infra code, and that the ops team have their work to do at
yeah,
the
yeah.
same time as the development team, right?
Yeah,
Yeah,
and documentation is also coding if you're using Markdown and so on.
yeah.
That's funny, but that's true that you can read it as a developer and oops, this loop it's almost the same. So I'll let you continue.
All right. So for what type of organization is it made of? So we talked about the two pizza-sized team. Does make sense, and it works very well for small organization, right? You have startups, you have digital factories. You don't have so many people doing more like individual tasks. You have a small team. You need to have people who are willing to learn new things, to work together, and go out of their comfort zone to implement the solution as fast as possible. So it's expected that DevOps is working well for this type of organization because you have a smaller structure, you have a smaller organization, and the communication is easier, right? So broader skill set, people learn from each other by communication, and naturally it can fall quickly into DevOps, and it is easier for them to adopt. But it's not only made for small organization, it is as well very well suited for large organization if you're doing it right. And I think that's all the important thing. We talked about the Conway's law and how the structure of the organization is fundamental to the output of a project and what you're going to release and build. And if you want to have a DevOps approach and methodology or teams with a large organization, you need to do changes as well at the organization level. So we have a few references of super large organizations that do things the DevOps way. We can talk, of course, about Microsoft, Amazon, Facebook, LinkedIn, right? They're all in the tech industry and they're all IT. But we have other companies doing DevOps as well. We can talk about American Express. We can talk about other retailers. We can talk about people in the financial industry or the energy industry. And it's all about the organization and how far you're willing to go to change the way you do stuff.
Now, we're
So
talking every time about digital transformation. I think the way of your work now depend on that also, and you will not change your company just like this. It will be very more complex. It will take time.
it
It
will
takes
take time, right? And
yeah, yeah,
it will
yeah,
be painful at some point because
yeah.
we're talking about changes and change is hard, right? You have some people who deal with change better, who embrace change, and you have people who are a bit more scared, a bit less willing to go out of their way, out of their comfort zone.
Yeah.
And that's really a culture shift, and it can be scary for some people, right? You see Microsoft on this slide, and we talk about DevOps, but when you think about the product stack like 10 to 20 years ago, it was not obvious that we were made to do DevOps.
Yeah.
When 10 years ago, 20 years ago, when we were releasing product, it was maybe once every 3 or 5 years, you had a major release for Windows, major release for Office, maybe Office 97, Office 2000, you name it. And essentially it was just like one bulk release, and there was very little less communication, I would say, between the teams. Now things are moving. We've changed the way we release products. We don't have anymore a version for Office. We have Office 365, and we do changes on a daily basis. Windows is the same thing, right? We have Windows 10, and Windows 10 has many releases, right? Biannual releases. You have the spring and fall releases. And we're not talking anymore about major shifts or major changes. We're talking about small evolutions to the product. So it required some changes. It required some restructure on like organization changes at Microsoft. And it took some time, it took some effort, but we've made it. And now I've been to Redmond last year. Obviously this year I couldn't go to Redmond because of COVID. Um, But when you see the old buildings and the new buildings from Microsoft, they're like totally different. And I was talking to the IoT team, and they essentially had a space and a budget, and they were free to pick their hardware, pick some of their appliances, and essentially being free to organize a space to be best suited for the organization and for the team. And every team is different, right? Every team has their own methodology. So essentially that is really empowering the team to be more autonomous and making decisions as a smaller team, not as a huge major organization. So that's the type of shift that you need to do if you want to be successful in DevOps. So culture shifts, organization shifts, and common accountability and shared responsibility. I think that's the key. Every organization can do it if they're willing to invest and if they're willing to transform as well. Right, so we've seen that DevOps is made for small and large organizations, but what are the benefits of embracing DevOps? We're talking about change, and change takes some time and some effort. So the main goal, one of the main goals of DevOps is beyond the communication is reducing the release cycle times. You have a smaller team, the team works together, there's less latency or less friction from moving to development to production because people know what they're doing. Most likely they're going to automate everything and they are accountable for everything. So if there's an issue, it will go faster to fix. So developing and deploying application, we'll use agile methodologies. We want consistency and most likely automation between development, testing, and production.
And remember, if you release the release cycle time between new features or evolution of your application, that means you will get an advantage if you compare with your competitors if they are not doing the same thing. Because you will be more agile to respond to the answer of the market of your customers. You will be quicker than your competitors, and the faster you are, the better you can be with your and response to your customers. The better the business will be at the end.
And we talk about release, but we talk as well about rollback. So doing a new release, being able to understand based on metrics what's going on, doing changes and moving on to the next version. What else? So what are the other benefits then? Fragmentation. You have smaller developments. We're not looking for major revolutions. We're looking at increasing the quality and the features of the application. You have obviously more releases, more branches, more versions, and you'll do that more often. If you have a look at social media, I think the last major change in social media was Facebook, but they haven't done a major change in multiple years. So they've done small evolutions, and at some point then you have to do a bigger change. So seamless updates, yes, you've seen, we talked about e-commerce website, I just talked about social media.
Windows is a good example also.
Windows is a good example, yeah.
Windows 10, every new version of Windows 10 every 6 months, you get some new feature, but it doesn't change anything. It's not a revolution. It's just an evolution of some component on the systems. Every time there is an update, except the time it takes you for updating your workstation, you don't say at the end, wow, everything has changed. I don't understand how to use it. It's more smooth. It's
nimble changes, yeah. And then at the team level, share responsibilities. You said that we all on the same boat. If something happens, it's not just finger pointing, it's all the teams that are accountable for that. And finally, continuous improvement. It's all about the release cycle and capturing some monitoring and metrics, knowing what works and what doesn't work on your application, and focusing first on the user experience and what you're delivering. So I will let's start and finish on this one with one of your favorite code. Not talking about development or infrastructure. You're talking about the bro code. So bro always helps bro.
Yeah. So this is the end of this first video of this series of microservice and Azure webcast. On the next video, we will coming to the introduction of the microservice. We will make the link between the microservice and the DevOps approach that we talk in this video. And we will see you later on this channel with Nicolas. And thank you, Nicolas, for your time.
Thank you, Stan.
See you in the next videos. Thanks for your time.